Well, this is going to be part two of my, shall I say, final analysis of flights around the world, comparing it with a globe Earth versus a flat Earth. I just finished talking about how I found online a data source that provided statistics on all of the US carrier-based flights for January of 2017. But in all of that research that I was doing, I was trying to find a way to get access to flights in the southern hemisphere. Specifically, I wanted to find flights that were from a location in the southern hemisphere to another location in the southern hemisphere. I was looking for an API that I could somehow access that would give me flight data in reasonably real time. I was not interested at all in real-time data. There were only a few fields that I was really interested in to compare the globe Earth versus the flat Earth. But after a little bit of failed research, I discovered that I was able to pull the data that I needed from flightaware.com. And so the way I did this was, here are all the flights that are currently in operation right now. And so if I go and pick a flight, so this is United Arab Emirates to Sydney, Australia. You can see that it left at 5:22 p.m., 4 hours ahead of UTC, and it is expected to land in 3 hours and 52 minutes. So the way that I figured out how to get the data from flightaware.com, and unfortunately you can only do this, it would seem, one flight at a time, is use your browser and turn on debugging. And I'm looking at the network column here. So all of the requests that this page is making will show up here. And you'll just have to wait a few seconds. At some point, you'll see a request to track poll. And I think it does this every minute like this. So once you see the request for track poll, I'm using Firefox, and there's a feature in Firefox. If you right click, you can say copy as a curl command. So curl is a tool that allows you to get a page on the command line. And so here's a terminal window that I have on my Mac, and I have a test script. And here are a few flights that I've done previously. So I'm going to go and get a new copy. I'm going to go and get this one. This curl command is for that flight. I am going to output to JSON 12. And this JSON file is the current date, hour, minutes, and seconds for the 12th flight that I want to track. So now I'm going to save it, and I'm going to run the script. And I've got two flights currently that I'm getting, and this number 12 is the one that I just tracked through this page. And so I wrote a fairly small Perl script that uses the JSON parser module that I got off of the internet. I'll probably write something up fairly quick that gives you a few basic instructions along with a copy of this JSON and my Perl file. Such as it is, I spent zero time in making it nice and pretty. And so here what I'm doing is I'm really only interested in these fields or these elements from the JSON feed. This is the output of this examine method that I've got commented out right now. It basically will recursively go through all of the elements of the parsed JSON variable, basically this sub-element of the flight itself. This is the output of this, so this gives a nice little print-friendly hierarchy of the JSON data. And the main things that I was really interested in from the JSON data were the geo coordinates for the origin and the geo coordinates for the destination, a print-friendly location for the origin, which would be more the city than the airport, and same thing with the destination. If it provides the actual landing times and the actual takeoff times, I'll use those. In some cases, if I can't find the takeoff time or the landing time, I'll go and grab the scheduled times instead. The distance, there's an actual distance flown and there's a flight plan direct distance. I find that these are usually not the same exact values, and I'll show that in a second, along with the current timestamp and what the distance elapsed in the flight happened to be. So I grabbed all of this data from the JSON file and I do a little bit of fiddling around. I check a few things and then I'll just output into a comma separated output that I can then paste into my Google Sheets. So Perl parse file, and I am interested in this new flight, and all of that does is it outputs these fields. For this video, these rows are the ones that I'm interested in. So I'm going to add another flight, and all I have to do is go data, split text to columns, and that outputs into these fields here. I'm going to go and copy all of these and put them over here. So according to FlightAware, the airline has posted a flight plan from Dubai to Sydney, Australia, with a scheduled distance of 6,511 nautical miles. These are in nautical miles. These are the geo coordinates for the two cities, or possibly the airports. I'm pretty sure this is the time elapsed, not the full time, and this column is the distance elapsed. So these two should represent time and distance elapsed, and as you can tell, this one is still currently in the air, 4,400 kilometers out of 6,511. These cells go and calculate a globe Earth distance using the Haversine function. I calculate the flight speed. So I'm taking this column, these columns, and this column into account to calculate a flight speed. Flight speed delta is going to be the difference between this and recomputing this. So basically, this allows me to compare what the flight speed should be relative to what the flight speed appears to have been based on the amount of time and the distance traveled so far. I convert the speed delta into kilometers per hour delta. So this is nautical miles per hour. I just convert it to kilometers per hour. The difference in the distance is done through a similar process. I take my globe Earth Haversine calculated distance, and I subtract from that the distance traveled so far. And then I also, if I look carefully and I rework this equation, I could just eliminate column L completely and just subtract this distance from my calculated distance. I started off using this distance, and as I was playing around with it, by the fourth or fifth or sixth that I was trying to get this working, I realized that this distance is probably not as critical as this one. This may have something to do with the airspeed and time rather than the ground speed and time, which is why these values don't seem to be the same value. So in this case here, ground speed was 2,633 nautical miles. This one estimated the flight distance to be 2,802 nautical miles, probably because it was fighting a headwind. So the difference in distance is calculated by subtracting the posted distance from the distance that I calculated using the Haversine function. This is expressed in nautical miles, and I convert to kilometers. So this column is the difference in kilometers between my calculated distance using nothing but the geocoordinates compared to the distance that the airline posted. As you can see, the difference is very small. 14, 12, 7, 11, 13, 12, 1.9, 1.4, so on and so forth. So the Haversine function, that is a formula to calculate distance on the surface of a sphere, matches very closely to the values provided by the airline when they submit their flight plan. If I compare what it looks like to a flat Earth, I explained in one of my previous videos, I think I might put a card right about here, How do you calculate distance on a flat Earth? So I'm using basic trigonometry, considering that the accepted flat Earth map is the AE map with the North Pole at the center. And radiating out from that point would be the lines of longitude, and the concentric circles around the North Pole would represent the lines of latitude. I use basic trigonometry to calculate the x and y coordinates on a flat Earth for the two geolocations, and then I use the square root of the sum of the squares of the other two sides to calculate the distance between those two airports, and then I work it out into nautical miles. And then from there, these other equations are pretty much the same as before. And as you can see, just like all of the other videos that I put out before, the flat Earth has wildly differing opinions as to the distances that flight should have taken. And in the case of this one that I just did as an example, it calculates a difference of 4,000 kilometers from what I computed to what they provided. And in contrast, using the Haversine function, the difference is only 14 kilometers. So I don't really consider this video as yet more proof. This really is more evidence of the same proof. All the calculations that I've done, all of the data that I've used, all indicate that the Earth is an oblate spheroid. It simply does not work for a flat Earth. NASA is not lying about the shape of the Earth. And hopefully this is going to be the proof that some flat earthers would need to convince them that we are not living on a flat Earth, and that they will reevaluate the accepted notion that we live on an oblate spheroid. So check the description below for links to the various resources that I talked about in this video. And if you like this video, I would appreciate the subscribe, the thumbs up, leave a comment. Don't forget to hit the bell to be notified of more videos, etc., etc., etc. And I'm going to see you again in another video soon enough. So bye for now.